In this video, we're going to talk about electrons and electron configuration. Electrons are located in the principal energy levels of the atom outside the nucleus. So we've talked about the fact that protons and neutrons are in the nucleus of the atom. Electrons are located outside. There's a special name for the electrons that are furthest away from the nucleus in the outermost ring. Those are called valence electrons. Those are the electrons in the last energy level of the atom. So for example, if you look at carbon, and we look at the numbers for the electron configuration in the bottom left of the box on the periodic table, we'll see that the last number is 4 because it says 2-4. The 4 would be the valence electrons. If you look at sodium, Na, number 11, the electron configuration is 2-8-1. Since the last number is 1, it has 1 valence electron. The electron configuration tells you how many electrons are in each principal energy level. So the electron configuration we're looking at is mainly the Bohr electron configuration, where we're looking at how many electrons are in each ring, kind of like planets, around the nucleus. So for example, carbon is 2-4, and you could find that on your periodic table. That means that there are 2 electrons in the first energy level and 4 electrons in the second energy level. We can represent the number of valence electrons in an atom by drawing something called a Lewis dot diagram. In a Lewis dot diagram, you draw the symbol and how many valence electrons are present around that symbol. For ions, we're going to show how many electrons are gained or lost. Negative ions are going to gain electrons, so we're going to show 8 electrons around the atom. Positive ions are going to lose electrons, so we're not going to draw any dots around the atom. When we draw ions, we're going to draw brackets around the symbol. We're going to put a charge, and we're going to put dots to show for negative ions when we've gained electrons. We're going to go through examples in class of how to do Lewis dot diagrams. As far as electron configuration goes, there's a maximum number of electrons that could fill each level. The first level can hold 2 electrons. The second level can hold 8. The third level can hold 18. And the fourth level can hold 32. This is important that we understand how many electrons can fill each level. If you look at your periodic table and the electron configuration, you could start to see that the pattern is developing 2, 8, 18, 32. Those are the maximum number of electrons that can fill each level. When we look at electron configuration, we can write an ion configuration for elements. So we talked about the fact that a positive charge indicates that electrons have been lost. So for calcium, if I look at the electron configuration on the reference table, it's 2-8-8-2. So if you just make sure that you pause the video at this point and take out your reference table so you see what I'm talking about. Plus 2 means that it's lost 2 electrons. So you should fill in here that you would have 2-8-8 as your new ion configuration. Cl minus. Chlorine on your reference table is 2-8-7. Since this is -1, has its -1 charge here, that means that it gains an electron, so it would be 2-8-8. And lastly, N is 2-5 on the reference table. This is -3, which really means that it would add 3 electrons, so it would also be 2-8. Lastly, we want to talk a little bit about atomic spectra. Wavelengths of light are produced when energy is absorbed and then released by the atom. Each element, so we'll look at this in a lab, has its own particular unique wavelength of light that it emits when it releases energy. And we could identify what each element is by the spectral patterns that it release. So for example, when we're looking at stars and we could see this type of spectral patterns that are released, we could identify the star, the elements in the star, because each element has its own pattern. Here are the steps that happen. An atom will gain energy, usually by adding heat, which causes an electron, this is important, that's the electron, to become excited. That means that the electron is going to jump to a higher energy. Unfortunately, the electron can't stay at this higher energy level. The electron can't stay at this higher energy level. So what happens is the electron falls down from the excited state down to the ground state. When the electron falls down, it releases all the energy that it had absorbed to go up. So it releases energy, and that energy is released in the form of light. That light is what we're going to use then to identify what the elements are. So we're going to do a lab with flame tests, and we're going to be able to identify what the metal ions are in the flame by looking at the colors of light that are observed as the electrons fall down from the excited state down to the ground state. And lastly, we could look at electron configuration for elements and see what it is in the ground state, which is the way it appears on the reference table. So for example, magnesium in the ground state is 2-8-2, means 2 electrons in the first shell, 8 in the second, 2 in the third. And look at, well, what does it look like when it's excited? When it's excited, one of the electrons has jumped to a higher energy level. So let's say one of the electrons in the second shell jumps to the third. That would give you 1 less in the second, so 8 minus 1 is 7, and 1 more in the third, so 2, 7, 3. We'll do more practice on what excited configuration means, but basically you're taking 1 away from the shell before the last and adding it to the last, or you could take 1 away from the last and completely start a new shell. You actually could excite something as early as the first shell. It's anytime an electron is excited to a higher level than the way it appears on the reference table, which is the ground state.